This video tutorial looks at the mathematical strand of measurement and geometry, and more specifically we're going to focus our understanding on classifying angles according to their size and looking at different angle properties. So when we're looking at classifying angles, we basically look at the size of the angle, and that helps us to determine how we would label that angle. Okay, so we can see here that a full circle or a full rotation, okay, or 360-degree rotation would be called a revolution. We know that a straight line or a straight angle has 180 degrees, so anything that's got 180 degrees is of a straight line or straight angle. And a right angle, we know, has 90 degrees. Okay, so a 90-degree angle is called a right angle. Anything less than 90 degrees or anything less than a right angle is called an acute angle. Okay, so that's an angle that's less than 90 degrees. An angle that is between a right angle and a straight angle, or between 90 and 180 degrees, okay, we call an obtuse angle. And anything that is greater than 180 degrees or greater than a straight line, but not a full revolution, or we can say between 180 degrees and 360 degrees, we call a reflex angle. Okay, really quickly, just some properties of angles. So angles at a point, okay, so angles that surround a point all add up to 360 degrees, and that's very similar to a revolution, okay, because they all add up to the same amount as a revolution, so 360 degrees, so all the angles around a point. The angles on a line, okay, add up to 180 degrees. Similar, so this is like a straight angle, okay, or a couple of angles that add up to a straight angle. All right, here, okay, this would be our straight angle, the whole thing, so we know that a combination of angles on a straight line add up to 180 degrees. And it's also important to know that angles that add to 180 degrees are called supplementary. They supplement each other. Angles in a right angle, we know add up to 90 degrees, and we just went through what a right angle was. And it's important to know that angles in a right angle are complementary angles of each other. And another thing too, just to keep in mind, is that when lines or line segments meet at 90 degrees, they are considered to be perpendicular to each other. That means meeting at 90 degrees. Okay, when we label angles, all right, we label both what you would call the arms of the angle and the point where the arms change direction, which is commonly known as the vertex. So you can see in the diagram down the bottom, we've got the vertex where the angle changes direction, and we've got the arms that make the angle by joining together. All right, and obviously the angle is the little bit inside. So when we label them, okay, we normally would label the arms and the point, and then we would write down the angle and what it is. So, for example, in our first example here, we would have the angle ACB. We try and do it in alphabetical order if we can, and you may see it written like this with a little hat over the middle letter. That means that's where the vertex is. Or you may also see it written like this, where it means the angle of A to C to B. Alright, so our second example over here would be written as CBD with a hat, or some people would write it with an angle CBD. Always make sure that when we write those, that the letter that's in the middle, alright, is the point where the vertex is. And ideally we would start the arm that has the earliest letter in the alphabet. Okay, so when we go to label angles, we can look at some example questions, and we need to label the arms and the vertex. So my first example, I might just label it ABC. Therefore I can say that this is the angle ABC with B in the middle with a little hat, because that's where the vertex is. Or I could say ABC, written like that, And we know this is an obtuse angle because it's greater than 90 degrees, but it's less than 180. In my second example, I might label it MNO. And in this particular case, the little hat would be on the N because that's where the angle changes shape. Or I could write MNO, and this is a right angle. We know it's a right angle because it's 90 degrees and it also has a little square. And my last example, I'm going to label it XYZ. So this is the angle of XYZ, or I could write it like this. And this is going to be a reflex angle because it is greater than 180 or 180 degrees, but it is less than a revolution. So we call it a reflex angle. Now the last couple of example questions, we're going to try and work out the missing angle. And we know in our first example here, it's a right angle, so the total is 90 degrees. So our x degrees plus 58 degrees must equal 90 degrees. And when we work that out, we would find that x equals 32 degrees. In our second example here, we know it's a straight line, which means it's a total of 180 degrees. So x degrees plus 72 degrees plus 78 degrees equals 180 degrees. X degrees plus 150 degrees, because that's what 72 plus 78 is, equals 180 degrees. Therefore, x degrees will equal 30 degrees. And in our last example, number 3, this is angles at a point. And we know that angles at a point have 360 degrees. We also know that this is 90 degrees here because of our little right-angled square. So we could say there's 3 lots of A plus 90 plus 120. That's going to give us 360 degrees. 3A plus 210 degrees is equal to 360 degrees. Therefore, 3A is going to be 150 degrees, and A, therefore, is going to be 50 degrees. Okay, so here are some practice questions I'd like you to have a go at about determining the size of missing angles. Please feel free to pause the video and work them out. Once you think you've got the correct answers, continue the video and we'll see how you went. Okay, in our first example, we had Q degrees plus 52 degrees equaled 90 degrees because this creates a right angle here. We know a right angle is 90 degrees. So we end up with Q equaling 90 take away 52, which is going to give us 38 degrees. In our middle question, we know it's angles around a point, and angles around a point add up to 360 degrees. So we have 2 lots of S degrees plus 50 degrees plus 56 degrees plus 104 degrees equaled 360 degrees. When we add or collect these like terms, we get 200, so 2s plus 200 equals 360. Therefore, 2s degrees equals 160 degrees, and s will therefore equal 80 degrees. In our last example, we know it's a straight line here, so that's going to equal 180 degrees, because the straight line or straight angle is 180 degrees. So therefore we've got b degrees plus 41 degrees plus 54 degrees is equal to 180 degrees. When I add 41 and 54, I get 95. So b is going to equal 180 take 95, and b is therefore going to equal 85 degrees.